All right. Hello, everyone. I'm Mehrin Kiani. I work as a machine learning scientist at Protect AI. Very excited to be here and to talk about the security of machine learning models. But first, I'm going to figure out how to use this. So, all right, works. All right, so in today's presentation, I'm going to talk about how machine learning models are now a part of the ML supply chain. This and combined with the fact that machine learning models can be compromised has made for a very potent attack vector for attackers to make model serialization attack. And we have seen this prevalent on model hubs already. So this is not a theoretical threat, it's already happening. And so, to gain a better understanding and appreciation for MSA, we'll try to, dig deep into, how we can, craft our own MSA. So we'll take a PyTorch example for this case. And if there is one thing you can take from this presentation today, I appreciate it's rather late and do acknowledge, all of you coming here, is to please scan your machine learning models. It's very important. So first off, the trend that machine learning models, back in the day, they were trained from scratch in-house, which was, great. You had the whole control over the machine learning model. But now as machine learning models have grown in size, especially with the advent of large language models, it's no longer time and compute wise that you train the models from scratch, unless you are, very GPU rich. And so what model hubs have done, they have started hosting these pre-trained or foundation models on model hubs, which is fantastic. It has democratized AI, has paved the way for those who may not have the same resources to experiment and innovate, and that's just amazing how that has helped with the pace of ML innovation. But at the same time, there are consequences for, when things are placed in, open source. There is a community attitude. There is implicit trust that we do need to acknowledge here. And so this is how, the trend is nowadays that, if we have a machine learning, let's say, use case, we take a foundation model from a model hub, could be Hugging Face, TensorFlow, or Kaggle. And so then we fine-tune the foundation model on, let's say, our proprietary data or for particular use case. And then we can, when it's all fine-tuned and we are happy with it, we can also push it back to Model Hub. So this is all great. As we said, it helps with the pace of innovation. But we do need to understand that anyone can upload and download a model from these public repositories. And just because a model is publicly available, that does not mean it's also safe to use. And so, now that we understand, that machine learning models are a part of our, supply chain, let's spend some time understanding what exactly is a model serialization attack. So essentially, when we have a machine learning model that, let's say, we have fine-tuned or trained, and now we want to, save the model. So that process is called serialization. We essentially convert the machine learning model into a byte stream, and it contains not just the tensors and the weights, but also the loading instructions for that particular model. On the other end, when we want to, let's say now, bring the model back into memory, these instructions, that were saved, during serialization, they get executed, and the machine learning model is, kind of like put back together for the, user to use. And this is great because it makes for a very all-inclusive machine learning model file. It's a seamless experience. There are no, few kinks, and so, helps with the whole machine learning process. But at the same time, an attacker can also, inject malicious code during saving time. And then when model is saved and, let's say, distributed, when you are now ready to load a model back in memory, those malicious instructions, could execute on your ML system and compromise it. And so what are the, just tried to make this more simplistic from an attacker's perspective so we can appreciate it more. What are the steps that an attacker needs to take to, let's say, make a model serialization attack is, first download a model from a model hub. Could be a llama model or whatever is the latest, trend to make, way for traction. So others can also, make for their attack to, go widespread. So we take this, the attacker can take this foundation model, put malicious code inside this model file. Now this is a compromised model, and now they can push this back to any model hub. And so now this model is, if any unsuspecting user is going to download it and load the model, the malicious code that the attacker has injected in it, it will execute. And so from a victim or from a user perspective, who doesn't realize that the model that they have just downloaded from, a model hub is compromised, they don't have to go out of the way to have this attack unfold on their system. So the sheer act of loading a machine learning model will execute those instructions, and the compromised model will basically pave way for the attack to unfold on their system. There is no extraction is required. The MSA can include, data exploitation, credential theft, model theft and poisoning. So this is basically what you see over there is the new pipeline here with the compromised model. And just the sheer act of loading would essentially have the MSA delivered. And so a couple of points for what makes model serialization attack potent, covert, and effective is that, one we already discussed, that it's the sheer act of loading a model is going to execute those instructions. Two, traditional scanners, they don't pick the malicious content in a machine learning model. And so, your traditional scanners won't be able to, give you any insight if a machine learning model contains something malicious in it. And the third point to note is that it does not impact the performance of a machine learning model. So, for example, if it was a classification model, the behavior would continue as is. So, it will be able to classify just as all right. So, from a user's perspective, if their system has been compromised because of model serialization attack, they will not be able to, appreciate that their system has been compromised because one, they just loaded the machine learning model, which is a very standard step, and two, the performance of the machine learning model, continues to be, as they expected. So there is no, out of the blue, behavior that would flag it for them. So all of this combined makes for model serialization attack to be, a very real attack vector. And here are some machine learning frameworks which can be impacted by model serialization attack. So for the classical machine learning libraries, which use Pickle for serialization. Pickle has a very prominent warning in their docs that don't use Pickle. It can be used to construct malicious files, and so, which can execute arbitrary code. So only on Pickle data that, you are, you're certain, you trust those sources, only unpickle those data. And then for PyTorch, it also uses Pickle under the hood. And so you will see a similar warning in the PyTorch docs too, that this is, it is possible to construct, files which, may execute arbitrary codes. So, only load those files which, you trust and coming from a verified source. For the case of TensorFlow, there are some operators such as, read file or write file that can be exploited. For Keras, there is the Lambda layer that allows for arbitrary code execution, so attackers can use those to construct MSA. And so at Project AI, we joined forces with Hugging Face, which is one of the largest machine learning model repositories. It has over 1 million models, and we scanned the machine learning models on Hugging Face to see the prevalence of MSA. And so in April, we published this blog. We scanned over 1 million models and found north of 50,000 models to contain unsafe and suspicious content. So this is, very much prevalent. Here is an example of a model repo on Hugging Face. So now from the look of it, there was nothing wrong. Nobody could tell that this particular file contains anything malicious. It's now been taken down, so it's all good. But just trying to tell you that this at some point was a live threat. And when we opened the model file and looked inside it, we decoded the attack and found that the attacker was trying to get the environment variable and trying to send it to a server. And now, things have changed because of our partnership with Hugging Face. And so now you will see next to each model file, a helpful banner telling whether a particular model file is safe or unsafe. And if you click on it, then it will also give you a link for why it thinks that a particular file is unsafe. You click on that link and you will end up on InsightDB. It's again all publicly available, so you can go and see what did Protect AI find in that particular file that it has flagged for suspicious or unsafe, and go from there. And so now the fun part begins. So how do we craft our own MSA? So we'll put on our hacker's hat and just follow these steps for what an attacker would also do. We'll start with download a model from a hub, and then we'll inject some executable but benign code in the model. We'll load the model back on the system, and we'll see that the model serialization attack has unfurled. And yeah, so this is the model scan repo, which has all the notebooks for PyTorch, TensorFlow, and Keras. If you would like to follow along, it's publicly available. There's a QR code too. And so yeah, if you navigate to notebooks, they have all the code that we'll look into. I'll just highlight the steps, but the repo has everything that you would need to reproduce the MSA. So for PyTorch, the first step is that we download, let's say, a BERT model from Hugging Face. It can be used for classification task. So in this case, we're going to do sentiment classification. And so we save the, download the model, and then we save the model locally. And the second part is to inject malicious code in this model. And so in this case, we are using the system command, and we want to see the AWS secret keys here. And then we are going to make a payload. Again, the function get payload and the class pickle inject is all available in the model scan GitHub repo. So do have a look there too. But essentially, the idea is that we are going to inject this malicious code in the model, and we are going to save that. And now, when we want to, predict a sentiment, let's say stock market was bearish today, we see that the overall sentiment, is given by the model as negative, and also giving a score to. So the model is behaving, as we expected. It's a sentiment classification model, working quite all right. Because we did want to demonstrate that, so I've got the AWS keys printed, so we could see that those. Command was executed, but in the case that we saw earlier, they can be sent to another server, and so you would not really know that your ML system has been compromised because you just really only loaded the model. Okay, and so how do we scan for model serializations attack? So Model Scan is an open source tool. It's available, the code is available on GitHub. It's also available as a PyPy package. And so once you have installed that, pip install Model Scan, and then you can just give it a path to the model file that you want to scan for, and then it will give you a severity result. So depending on what it finds inside that model, it could be critical, high, medium, or low. And then it does cover some of the popular machine learning frameworks too. And here we have just wanted to share what a scan result report would look like on the terminal. So once you've given the path, it will tell you that it is scanning this particular file. will tell you how many issues it found. If it find anything in critical, it's also going to give you that detail that it found a particular operator from which module. So, the user has more insight into what a particular machine learning file contains, and they can make an informed decision whether they want to, go ahead, load a model or not. And so, the idea really is, the appreciation that, we should not be trusting machine learning models blindly. Even, a file that gets, sent to our, Gmail, that gets scanned, and machine learning models that can execute code, we are not scanning them. So, just wanted to share that, we should have more appreciation for, what are we loading in our machine learning systems. Also, a question that I often get asked is, when is a good time to scan machine learning models? So I think the first place could be that, when you pull a model from a model hub, that's probably a good point to scan your machine learning model, that, it's all good to load. And then when you have done the fine tuning or whatever it is that you wanted to do with that model, and now you're ready to share it with your colleagues or community, probably a good idea to, run the scan on it again to make sure everything is still good and safe before putting it out there. And so the key takeaways are that, machine learning models have become a part of the ML supply chain. They can execute code and can be compromised by MSA. And so, please scan your machine learning models. There's an open source tool. It's publicly available. It's free. Use that. So yeah, with that, I'd like to thank you. If you have any questions, happy to take them now, or feel free to email me too. Thank you so much.
Hi, I'm curious on the effectiveness and the accuracy of Protect AI. Are there a lot of false positives or false negatives? Like if you get a lot of warnings that aren't warnings, et cetera?
Yeah, it's a very good question. I think we always are debating how to balance this, between false positive and false negative. And so, Model Scan is also an active development. We also have an enterprise version for it too, based on the customer feedback. We also have, settings too. Especially in the enterprise level, where you can, turn the knobs of how much false positive or negatives you want. So it's always utility between security. You have to balance these two. So depending on the use case, we do try to be user friendly and give them the control of how much they want to be nudged.
Hi, thank you for the presentation. Just one question: is this like a vulnerability only for publicly accessible repository? Like, what if we have strong authentication, access management, and also like integrity check? Are we still vulnerable to this attack?
So if I'm understanding the question correctly, you're saying that if there is a private model, is that still vulnerable to attacks?
Yeah, so if we have private repo and we have strong authentication and access management, are we still vulnerable to this attack?
Yeah, very good question. So I think it depends on, I think the overall security hygiene of that enterprise. I think because machine learning models and also the data sources, they do often change hands. So I would love to trust everybody, but I think it's always a good idea to scan them. So you do, when you have a private repo, you do shield it, have a shield around it from all the public actors. But what if within the organization you have somebody who plugs in something? How would you check for that?
Hi there. I'm just wondering if the precision of the model has any effect on the accuracy.
Sorry, the precision of the scan has an impact on the...
If the precision of the model has an effect on the accuracy of the scan, correct. Yeah.
Precision of the model has an impact on the accuracy of the scan. No, I won't think so, because this is how the model works is independent of the as we just saw, the malicious commands that can become a part of the machine learning model do not really impact the performance of the model. So you could have just like we saw the keys, or you have any command appended to the model. So the model performance or behavior is as can remain as is and not be affected because of the malicious commands that somebody could plug in. So the scan actually looks for all those opcodes or operators that could be out of place, and then flags it, and has nothing to do with the overall workings of a model.